Hey everyone, today I'm going to start Interviewbit time complexity section. Now I'm going to bring the whole playlist of Interviewbit. This is the first section in Interviewbit called time complexity. Here it is, and we'll go to arrays and then math like that will go. And today we are solving time complexity bucket 1. But before doing this, let me tell you some basic things about time complexity. How do you calculate time complexity of an algorithm? So you basically have to calculate the number of instructions executed while running a function or an algorithm. After you calculate this, to find out the complexity in terms of big O notation, what we'll do is you will first eliminate constants. All constants you have to eliminate. And second, eliminate the lower order terms. We should only take care of the highest order term. We eliminate all the lower order terms. These are the basic rules to calculate the time complexity. Let's take an example. Let's take that number of instructions. Let's call this, let's say, f of n, where n is the input, is equal to n square plus n plus 1, where f of n is the number of instructions. And what is the big O notation of this function? What does the first rule state? Eliminate all the constants. You have eliminated this constant. And if you had a 5 here, you would also eliminate this. You should eliminate all the coefficients and constants. Let me write it here. Coefficients also. Now what does the second rule say? Eliminate the lower order terms. This is the highest order term in this equation. These are the lower order terms. You eliminate all of them. What would you get as a result? N square. So this is big O of n square. This is how you basically calculate the time complexity. And one thing you must note here is this is only for iterative things, iterative algorithms. This is not applicable for recursive algorithms. Okay. Now let's take a look at the recursive algorithms. For solving recursive algorithm, you have to write a recurrence relation. Just give me a minute. Recurrence relation. T of n is the recurrence relation. And recurrence relation, for example, let's take the Fibonacci function, where the input is n. If n is equal to 0, you will return 0. If n is equal to 1, return 1. Now base cases are done. You will return f of n minus 1 plus f of n minus 2. Now look at this function. This is the Fibonacci function. Here the input is getting reduced by 1 and 2, and the function is calling itself. So how can you write the recurrence relation? And this is the constant number of instructions. This does not depend on n value. So we can write the recurrence relation for this function as t of n is equal to t of n minus 1 plus t of n minus 2 plus c, where c is constant, and this constant is these instructions, which take constant time. So this is how you express recurrence relations. Got it? Sorry. Now let's have a look. You have written the recurrence relation. Now how will you get the time complexity out of it? Okay. Now let's take an example and solve the recurrence relation. Let's take t of n is equal to 2 times of t of n by 2 plus c. This is the recurrence relation given to you, and you have to find out the time complexity of this recurrence relation. And the most easiest method to do this is recursion tree method. Recursion tree method. And what will you do in this recursion tree method? You take this as the root and break it down to subproblems. You go on building the tree. Okay. Now what should you find? For what function should you find the time complexity? For this function, take this as the root, t of n. How can you write t of n? C and 2tn by 2. I hope you got it, how I have written it. And the total, if you calculate the sum of all nodes of this tree, you will get the time complexity. Okay. This is how you get the time complexity. Now similarly, you break this down also. T of n by 2, how can you write T of n by 2? T of n by 2 is equal to 2 times of T of n by 4 plus C. Okay. Now replace this T of n by 2 with C and write the tree again. T, 2 C's, and this becomes T of n by 4. This becomes T of n by 4. This also becomes T of n by 4. And this also becomes T of n by 4. Right? Now it continues to go downwards. When will it end? That's the point. And here you will be given the base conditions. If n is equal to 0, T of 0 is equal to 1. Okay. So for how much time, for how long this tree will expand? Until, and T of 1 is also constant. These are the base conditions. For how long this tree would expand? Until this n becomes T of 1. All leaf becomes T of 1. Right. Now let's draw this again. I have exhausted the page. Okay. Yes. C, 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 and it goes on until T of 1. Now the sum of all nodes of this tree will give you the time complexity. sum of all nodes is equal to time complexity. Now let's have a look how do you calculate the sum of all these nodes. Let's go level by level. The first level has C, and the second level gives us 2C, and the third level gives us 4C, and then 8C, and so on. Right? How do you generalize this? Level 0 has 2 power 0 C. Level 1 has 2 power 1 C. Level 2 has 2 power 2 C. Level 3 has 2 power 8 C. Level K has 2 power KC. Understood? And when this is the uh, sum of nodes of this is the sum of nodes of the kth level. Okay. Now you have to add all this up. What will it give you? C plus 2C plus 4C plus 8C and so on until 2 power kc. Right? Now let's have a look at this. You have to find out the k. How will you find out the k? Now if you remember, this was t of n, and this was t of n by 2, and this is also t of n by 2. And this t of n, this n value keeps on reducing until it becomes 1. This is t of n by 2 power k. You get the k value by solving this equation. N by 2 power k is equal to 1 implies 2 power k is equal to n. Apply log on both sides, which will give you k is equal to log n. You got the k now. You got the level. You have to find out this sum. Where is it? You have to find out this sum to get the time complexity. Now how will you solve it? Have you done your geometric progression in your math class in 10th? Probably you might have. I'm sure you had. So this is a GP which has a value is equal to c and r value is equal to 2. And how many number of terms are there in this equation? Yeah, there are, this is 0, k is equal to 0, k is equal to 1. There are k plus 1 terms in this equation. So how will you solve it? Sum of GP formula is a into, when r is greater than 1, r power n minus 1 by r minus 1, which will give us c into 2 power n, where n is 2 power k plus 1. K is log n plus 1 minus 1 by 2 minus 1 is 1. Now we can write this as c is equal to c into 2 into 2 power log n minus 1. 2 power log n is n. So this will give you c is equal to 2n minus 1. Now how will you write it in terms of big O notation? Now you got the number of instructions is equal to 2nc minus c. What should you do? Remove all the constants and remove all the lower order terms, which we don't have here. So this is a big O of n. This recurrence relation given to us is big O of n. Where is it? This is big O of n. I hope you enjoyed the video. This is all for today. From next video, we'll solve the problems. Thank you very much.